C#.
C# and the .NET Framework are two components created by Microsoft to empower programmers to build any type of Windows application. C# is commonly used with Microsoft's .NET Framework, although that is not a requirement. C# is a general-purpose, type-safe, object-oriented programming language. The goal of the language is programmer productivity. C# was designed by Anders Heilsberg, who is no stranger to language design. He is responsible for creating Delphi and Turbo Pascal. He worked on Microsoft J++ when he first arrived at Microsoft and then became the lead architect for C#. Years ago, Bell Laboratories created the C programming language. It became popular in certain programming circles and spawned a long list of similar languages. Here is a partial list. Some of the more popular ones are Java, C++, Perl, PHP, and JavaScript. Like all these C-like languages, each is distinguished by their case-sensitive code, the use of curly braces to delineate code blocks, they use a semicolon for a line terminator, and consider white space to be insignificant. C# is decidedly a member of the C family and has familiar C-like syntax. I'll cover details of all the syntax requirements in a later chapter. There is more to C# than just C-like syntax, however. C# is OO compliant and supports all the major pieces of object-oriented principles, which include inheritance, encapsulation, and polymorphism. For years, the OO community has touted the class type in traditional OO discussions. In fact, the class is considered the prototypical OO type. C# supports several other types, however. For one, there is the struct or structure. This is a lightweight entity that is useful for simple value types. On the inheritance side, each C# class can have only a single base class. For other scenarios, including multiple inheritance, C# defines the interface type. An interface is similar to a class, except that it only contains type definitions, no code implementation. Another major cornerstone of OO is encapsulation. Encapsulation means creating a boundary around an object to separate its external behavior from its internal implementation details. C# utilizes a unified type system for this. The fundamental building block of code in .NET is an encapsulated unit of functions and data known as a type. .NET employs a unified type system, which means that all types share a common base type. Therefore, all types, whether they are simple primitive types or complex API or business types, share a known set of common functionality. C# relies on the .NET runtime to perform automatic memory management. The CLR has a garbage collector that executes as part of your program, reclaiming memory for objects that are no longer referenced. This is similar to the way memory is managed in other frameworks like Java. This has major benefits. If you have ever spent time debugging memory problems, you know that they can be nasty, hard to find bugs. Having a garbage collector removes the need to explicitly free the memory for an object, eliminating the problem of broken pointers encountered in languages such as C++. C# is predominantly a type-safe language, meaning that types can interact only through conventions they define, therefore safeguarding each type's internal consistency. For example, C# prevents you from interacting with a numeric type as though it were a string type. More precisely, C# supports static typing, meaning that the language enforces type safety at compile time. Static typing eliminates the substantial number of errors before a program is even run. The compiler verifies that all the types in a program are used according to their master design. Additionally, static typing allows tools such as IntelliSense and Visual Studio to assist you while writing a program. It should be pointed out that C# also uses dynamic type safety, which the .NET CLR enforces at runtime. In other words, the .NET runtime doesn't trust your compiler and verifies that every line of code is type safe before permitting it to run. C# is called a strongly typed language because it enforces the type rules very rigorously. For instance, you cannot pass a floating point number into a function that's intended to accept a string, unless you first explicitly convert the floating point number to a string. That makes it less likely to produce faulty code. All C# code is ultimately compiled to an intermediate representation that is processed by the .NET runtime. Most C# features are really .NET features called by your C# code or by the CLR. For example, If you write an error handler using the C# try-catch keywords, those are turned into .NET constructs. When an error occurs at runtime, it is the CLR that leaps into action to handle the error. It finds the correct exception handler, walks the call stack, triggers any finally blocks, and does whatever else is necessary as prescribed by the .NET Framework engineers. The design of C# closely matches the design of the CLR, which provides dozens of useful runtime features like garbage collection and the thread pool. Therefore, you can be assured that if the CLR has a feature, it will be a first-class construct in C# too. I think I spent enough time talking about C# ideals. Explore the other chapters to get more concrete examples of how to work with C#.